Hello everyone, welcome back to uLearn Education Online channel. In the previous video, we have seen how to draw the frequency spectrum of single tone AM signal. Now in today's video, we are going to see what is a multi-tone AM signal and how to draw the frequency spectrum for a multi-tone AM signal. So the multi-tone AM signal is nothing but the message signal which is having more than one frequency component. Then that resulting signal we are calling it as a multi-tone AM signal, which means if I write the example, then M of t is consisting of multiple number of frequencies, that is FM1, FM2, FM3 and so on, FMN. Okay, which means that this M of t is having multiple number of frequencies, and these frequencies will have a relation, that is FM1 is the lowest frequency compared to FM2 and so on, and it is the lowest frequency compared to the nth frequency component. So this relation has to be maintained, and also the amplitude of FM1 frequency. Let us suppose it is a AM1. This amplitude is less than the second amplitude frequency and so on, less than the nth amplitude frequency. Okay. Since the amplitudes is less, therefore from the definition of modulation index, I can write M1 is less than, M2 is less than and so on, Mn, nth modulation index. So these are the assumptions that we have to kept in mind while drawing the frequency spectrum of a multi-tone AM signal. So let us see how to draw the frequency spectrum of message signal, carrier signal and AM signal. So let us consider message signal of a multi-tone AM signal is consisting of two frequencies, that is FM1 and FM2, and which is a cosinusoidal signal. So I can write it as cos 2 pi FM1 into t plus its second signal amplitude is AM2 cos 2 pi FM2 into t. Here we have to make the assumption, that is the amplitude of first signal is less than the amplitude of second signal, and also the frequency of first signal is less than the frequency of second signal. Now in order to draw the frequency spectrum, first we have to apply the Fourier transform to M of t. So if you apply the Fourier transform, here it is a Fourier transform of cos 2 pi FM1 into t, which means it is an impulse signal with a shifting frequency of FM1. And the second term is again cosinusoidal signal, and here the shifting frequency is an FM2. So directly I am writing the expression, that is Fourier transform of M of t value will be M of f, and its value is equal to AM1 by 2 into del of f minus fm1 plus del of f plus fm1 plus second term is am2 by 2 into del of f minus fm2 plus del of f plus fm2. So this is the final Fourier equation for the message signal that we are considered. Now let us see how to draw the frequency spectrum. Okay, so the frequency spectrum of message signal is having a 4 frequencies. So 2 are a positive frequencies and 2 are a negative frequencies from the equation. So here the positive frequencies are FM1 and FM2, whereas the negative frequencies are F minus FM1 and minus FM2. So if I draw the frequency spectrum, okay, so and it is M of F. Here what is the first equation? It is FM1. We have to make an assumption, that is FM1 is always less than FM2. So here first signal is FM1, which is always less than FM2. So it is FM1 and which is having an amplitude AM1 by 2. Okay, and the next one is minus FM1. Next negative side we will draw later. Here say the positive frequency, that is FM2, and its amplitude is AM2 by 2. Here we make an assumption, that is AM1 is less than AM2. So which means the amplitude value will be high for the frequency FM2. So it is AM2 by 2 and its frequency is FM2. Okay, now let us see the negative term. So here FM2 value will be high in the positive case, whereas in negative case its value will be less compared to the FM1. For example, if I consider FM1 as 1 kilohertz and FM2 has 5 kilohertz, so in positive case its value will be greater, that is FM2 is greater than FM1, whereas in negative case minus 5k will always less than minus 1k. So here FM1 in negative side is greater and FM2 in negative side is smaller. Okay. So this is how to draw the frequency spectrum of message signal with the assumption of two signals. Now let us see the carrier signal, and here the same procedure will be repeated for the carrier signal. That is, we have to assume the equation AC cos 2 pi fct. Now simply apply the Fourier transform to carrier signal. So finally its value is AC by 2 into del of f minus fc plus del of f plus fc. Now the frequency spectrum how we'll draw? First identify the signal from this equation. So it is an impulse signal with a shifting frequencies of fc and minus fc with an amplitude AC by 2. So the carrier signal expression and frequency spectrum will be repeated for frequency domain analysis and also for single tone modulation, thereafter for the multi-tone modulation. Now let us see how to draw the frequency spectrum of amplitude modulated signal. Okay. Now we know the time domain expression of amplitude modulated signal. So if I write the time domain expression of amplitude modulated signal, then S of t is equal to C of t into 1 plus Ka m of t. Okay, so here C of t value is AC cos 2 pi fct and Ka is an amplitude sensitivity and its value is 1 by AC, and the m of t expression is AM1 cos 2 pi FM1 into t plus AM2 cos 2 pi FM2 into t. So this is m of t expression. Now substitute these three values in S of t. Therefore we will get finally S of t as AC cos 2 pi fct into 1 plus Ka is 1 by AC and m of t is AM1 cos 2 pi FM1 into t plus AM2 cos 2 pi FM2 into t. Okay, now multiply this equation. And then it is AC cos 2 pi fct plus, now let us write AM1 by AC. It is nothing but a modulation index of first signal or first information signal. I can write it as AC into M1 into cos 2 pi fct plus, and the second signal AM2 by AC. It is a modulation index of second signal, that is M2 I can write. Then it is AC into M2 into cos 2 pi FM2 into t cos 2 pi fct. Now how to write cos A, cos B signal? So here I have missed it, that is cos 2 pi fmt. So cos A, cos B, nothing but cos of A plus B plus cos of A minus B by 2, and here we have to consider the A value is the highest frequency and B value is the lowest frequency. Okay, if you consider the sign term, that condition has to be considered, whereas for the cos of negative is always a positive. We have that advantage. So if I simplify this equation by using a trigonometry expression, then I will get the S of t value as S of t is equal to AC cos 2 pi fct plus AC into M1 by 2 into cos of 2 pi of fc plus fm1 into t, okay, plus AC into m1 by 2 into cos of 2 pi of fc minus fm1 into t. So this is the trigonometry expression of first signal fm1. And for the second message signal, simply use the same transformation, then value will be AC into M2 by 2 cos of 2 pi of Fc plus Fm2 into T plus AC into M2 by 2 into cos of 2 pi of Fc minus Fm2 into T. Okay, so this is the final expression. To get the frequency spectrum of amplitude modulated signal, we have to apply the Fourier transform to S of t expression. So if you clearly observe, this S of t expression contains only a cosinusoidal signals. So finally, I can say that the entire frequency expression of AM signal will contains only an impulse signals. So by directly using the Fourier transform of cosine formula, I can directly write the equation as S of f is equal to AC by 2 into del of f minus fc plus del of f plus fc. So this is the first term. For this term, here the value of frequency is fc plus fm1. So I can write it as AC into m1 by 2 into 2 is 4. Why? Because Fourier transform of cos is 1 by 2 into del of. So 2 into 2 will be 4. And I write then its value is del of f minus fc plus fm1 plus del of f plus fc plus fm1. Okay, and the next expression is plus AC into m1 by 4 into del of f minus fc minus fm1 plus del of f plus fc minus fm1. And for this, the Fourier transform value will be AC into m2 by 4 into del of f minus of fc plus fm2 plus del of f plus fc plus fm2. And for the last expression, then its value is AC into m2 by 4 into del of f minus of fc minus fm2 plus del of f plus fc minus fm2. So this is the final expression of Fourier or frequency expression of amplitude modulated signal for a multi-tone case. Now let us see how the spectrum will be for this multi-tone AM signal. So if you clearly observe, how many positive frequency components it will have? So positive Fc and positive Fc plus Fm1, positive Fc minus Fm1, again Fc plus Fm2, Fc minus Fm2 means 1, 2, 3, 4, 5. Okay, so 5 positive frequency components will be present, same as the negative frequency components will be 5. And here this Fc value will be a carrier signal frequency. Okay, and here Fc plus Fm1 is a highest frequency compared to the Fc frequency, and also here this Fc plus F2 value will be the highest frequency compared to the Fc plus Fm1. Why? Because we are making an assumption that is the first signal frequency, that is Fm1, is always less than Fm2. So we have to keep in mind while drawing the frequency of or spectrum of an AM signal. Okay, so if I draw the frequency spectrum of AM signal, then it simply looks like so total 5 frequency components will be present. I am drawing only the single sided frequency spectrum. So here the single sided indicates only positive frequencies will be represented. Okay, and it is a zero frequency. Now what is the first frequency component? Here the first frequency component is an Fc with an amplitude AC by 2, and here we have to check that which is the highest amplitude. So here AC value will be higher compared to the amplitude of message AM, and here we are having a two message signals, that is AM1 and AM2 amplitudes, and those are represented in terms of modulation index, that is M1 and M2, and here M1 is less than M2. Okay, which means the highest value will be AC by 2. Thereafter, the next amplitude is AC into M2 by 4. Further, its amplitude is AC into M1 by 4. Okay, so if I draw, the first frequency component value will be Fc with an highest amplitude of AC by 2. So its amplitude is AC by 2 and its frequency is Fc. And next, see what is the positive equation, that is Fc plus Fm1. So it is greater than Fc and its amplitude is AC into M1 by 4. Keep in mind that this frequency, that is Fc plus Fm1 value, will be less than Fc plus Fm2, and its amplitude is AC into M1 by 4. So I can draw the expression as an impulse signal like this, and its value is Fc plus Fm1 and its amplitude is AC into M1 by 4. Okay, now let us see what is the third equation, and here the third equation is Fc minus Fm1. Okay, so its value will be less than Fc. So finally I can write this value is less than Fc and it is having the same amplitude. So the frequency spectrum is Fc minus Fm1. Okay, now next see what is the fourth one, and the fourth one is again Fc plus Fm2, which is a higher value compared to Fc plus Fm1 and is having an amplitude AC into M2 by 4. So and the fourth frequency component is Fc plus Fm2, which is having an amplitude of AC into M2 by 4. And what is the last frequency? Then it is Fc minus Fm2. So its value will be less than Fc minus Fm1. So here it is Fc minus Fm2. So this is how to draw the single-sided frequency spectrum of AM signal. If you want to draw double-sided, then consider the negative portion. Okay, then we will get the full-sided frequency spectrum of AM signal for the multitone modulation. Thank you for watching our videos. Keep supporting.